today's session, right? So hydrocarbons, today we are going to see about what? Alkynes, right? So in the last class, we have seen about what? Alkenes. We have seen isomerism and all, right? So now, guys, have you seen this type of compound ever? This is what? I hope everybody is well versed with these things. So we are going to see some compounds containing alkene or alkynes in this today's class. Okay, Ganesh, fine. So in the last class, we have seen this chair conformation, board conformation, right? So these things we have seen in the last class only, right? Now, this is what alkene, guys. How the alkenes are there? C double bond, carbon double bond, carbon. This will be what? Either it can be what? Hydrogen, or it can be what? Or any methyl group can be there. CH3 can be there, or there can be what? H can be there. Here also same thing can be there. So these are what? Alkene. Now, we are going to see addition reaction. What is the meaning of this addition reaction? Who will tell me? Addition means what? There will be something that will be adding there, right? Something that will be adding there, right? Without displacing anyone, right? So without displacing any atom, you can say, without displacing any atom, you are adding something. That means what? Addition reaction is there. In case of alkene, addition of alkene, what will be happening there? Let's suppose we are having what? Attacking molecule A, and we are having what? B. So carbon double bond carbon is there, and we are knowing this pi bond is loosely bonded, and it can break down, right? It can break down very easily. Is it okay? So this A and B will attack to this carbon. Then if this bond will break down, right? If this bond will break down, so it will be a single bond there. So we'll be getting what? Carbon A, carbon B. That will be attacking reagent will be attacking this carbon and this carbon. But getting my point? So this will be what? A, and single bond what? We will be having B. Clear? Is it okay? Any doubt to anyone? Fine. Now, see. You can see here that double bond, this is what? Alkene. See guys, what will happen? If this double bond will break down, so the electron of this pi bond, this pi electron either shift towards this carbon or either will shift towards this carbon. If it will shift towards carbon number 1, so it will be having what? Minus charge. If it will shift towards carbon number 2, so it will be having minus charge. Else carbon number 1 will be having minus charge and carbon number 2 will be having positive charge. Is it okay? If it is, see, here we are having two, B and A. Again we are having what? B and A. One is what? Electronegative, that is having what? Minus charge, and one is what? Having A positive, that is partial positive charge is having there. So if minus charge over the carbon will be there, then this A will be coming to this carbon, and there will be what? A will be formed. That is what? And this carbon that we have seen, that is having what? Plus charge, that will be what? Carbocation, that we can see here. Now this minus from this carbon will attack this carbocation, and the new compound will be formed as an addition product. Is it okay? If you are having any confusion, then I am going to make you understand once again. Let's suppose we are having B and A. Let's suppose B is more electronegative. So B will try to pull out the electrons from A. Yes or no? Please tell me, guys. So B will be having minus charge and A will be having positive charge. Is it okay? Any doubt to anyone? No? Now see here. We are having carbon, double bond carbon, right? If the pi electron shifts towards this carbon, right? So it, yes, see here. So if the carbon, if double bond is shift towards this carbon, then minus charge will be over this carbon, and plus charge will be over this carbon, right? Clear here? Now see here. So minus charge. So this A will try to attach with this carbon because it is having what? Plus charge. So we'll be getting what? The new product that we'll be going to get is what? Carbon A. A will be here, right? Single bond, carbon positive. This will be there. Now, again, in the second step, this B will be minus negative charge will be coming to this carbon, positive one. So we will be having what? A, carbon. Again, now this will be having what? B, and this is the carbon. So this is what addition product that we'll be going to get here. Is it okay? Any doubt to anyone? No? No. So we can see this in the diagrammatic form as well. How this has happened. Electrophile has how shifted towards the carbon. How the carbocation has been formed. We can see in this diagram as well. So E plus is what? Electrophile. Right? Now, see here. Now we are going to see, for example, a specific example addition of HBr to ethene that we are going to see. This is what? HBr. Br will be having minus charge. H will be having what? Positive charge, because Br is what? More electronegative. Is it okay? Br is more electronegative. Now, what will happen? Here, this alkene, what will happen? If the pi bond is shifting towards left, then the right carbon will be having the positive charge, right? So we can make here, how we can do the addition product, how we can make the addition product. See, Br, more electronegative, so minus charge will be there. And hydrogen is less electronegative, so it will be having positive charge. Now we are having alkene, C double bond C, right? And H is there, right? Now, if this double bond is shifting towards this carbon, right? So there will be what? Br minus and H plus. So carbocation will be generated, right? So this carbon will be having positive charge, and this will be having what? Minus charge. This will be having what? Minus charge. So minus charge. This H will be going to join this carbon, right? This H plus will be going to join this carbon, right? So there will be a formation of what? How will you going to get the new product? The new product will be what? Carbon, right? H and C here. The minus will be having what? The minus carbon will be having what? The plus one, that is H, and the plus carbon will be having what? Br. So here it will be what? Br. So you can see here how this product has been formed, the addition product. Got my point? Is it okay, everyone? Now, addition of halogen. So we have seen the addition of what? Halogen. Sorry, addition of HBr. Now we are going to see addition of halogen. Right? Double bond is there, right? Br2 is there. So here there is what? 2Br is there. So double bond will be breakdown. Getting my point? In the presence of CCl4, what will happen here? This 2Br will be joining this 2 carbon. Halogen, particularly chlorine and bromine, react with alkene in the presence of inert solvent, that is CCl4, CCl form, to form dihalogen derivatives. So this is what? CH2, double bond CH2 plus Br2 in the presence of CCl4, right? So we'll be getting what? CH2, CH2, and then Br. Clear, guys? Any doubt to anyone? So this is what? Addition reaction, addition of halogen. that we have got here. If two Br will be there, so both the Br will be going to join this carbon. Clear? Any doubt to anyone? No. CH3CH CH2Br2 is there, and CC in the presence of CCl4. So Br2 is there. So these two Br will be joining these two carbon. Clear, everyone? Any doubt? No. See here. Again, you can see here propene, CCl4. We have got what? So Cl2 is there. This time Cl2 is there. So again, we will be getting what? ClCl at the second and third carbon. So the reaction with fluorine is explosive, whereas iodine does not react under the normal condition, right? So the reaction can be used as a test for alkene because the brown color of bromine will get decolorized by alkenes. So again, Br2 will be adding in this manner, and this will be what? Colorless. So we'll be having what? Br and Br. Now, it may be noted that the above test is also given by alkynes triple bonded compound. In fact, that test is used to detect the presence of double bond or triple bond in the compound, that is unsaturation. So in unsaturated compound, this will be happening. Clear? Any doubt? Now guys, see, addition of Br2 to alkene. We have seen that Cl2 we have seen, right? The similar way Br2 will be going to act, right? Double bond will be shifted towards this carbon, then minus charge will be there and plus charge will be here, right? Minus charge will be here, and then this Br can attack to this carbon. Those who are having minus charge, so minus will be C. Actually, nucleophilic attack, Br2 is there, so nucleophilic attack will be there, right? So we can see here how this will be happening. Carbocation, having the carbocation will be joining the Br, right? See here, CH2, C carbon, carbocation, CH2. So we'll be getting what? Br minus here, right? Attack of bromide ion, that is Br ion, on the attack of the positive charged carbon atoms to form addition product. So now you can see here, this is what addition product that we are having. Clear, everyone? Now see here. Addition of halogen acids, that is halogenation. Alkenes react with halogen acid HCl, HBr, HI to form alkyl halides. So double bond is there. Again, double bond will break down, and HX, H will be having positive, X will be having negative. So one will go with carbon, that like H will go to this carbon and X will be going to this carbon. Order of reactivity of halogen is what? That is HI, HBr, then HCl. Why I'm saying this HI? Because I is a better living group. Good living group, as it is having longer bond length. Good living group, right? Clear, everyone? Now we'll be seeing for the like symmetrical and unsymmetrical alkene in the next part. Got my point? See this figure, see this paragraph, then we will be looking ahead. I'm coming in 2 minutes. Clear, everyone? See here. Addition of HX. Again, H plus and X minus, right? Now, see here. This is for a symmetrical alkene, so there is no problem, right? This is what? Alkene and alkene is there. So H plus here, let's suppose pi bond is shifting toward this carbon. So it will be having minus charge and this carbon will be having positive charge. So this X will be coming to this carbon and this H will be coming to this carbon. So the product will be what? CH and CX, remaining will be what? Hydrogen. Getting my point? But this is for symmetrical alkene. This is for what? Symmetrical. Symmetrical means what? That is having 2 carbon. But for unsymmetrical alkene, what we are going to do? For unsymmetrical alkene, what we will be going to do? Is there anyone who can tell me? This is also for symmetrical alkene. For unsymmetrical alkene, there can be 2 products can be there. See here. Here there is 3 carbon is there. 1, 2, 3 is there. And here there is a double bond is there, right? Now we are having what? HBr. HBr is there, right? So clear everyone? So see here. Yes, see here. This hydrogen positive charge, this Br minus charge, right? Now we will be having 2 cases, right? This Br can either join this carbon. See, first of all, see this plus and minus charge, right? Now this carbon, this double bond, either can shift this carbon or this can shift this carbon. So let's understand first what will be happening if the electron is, let's suppose, shifting towards left. Guys, please try to understand here. If the pi electron is shifting towards left, so it will be having what? Carbon minus charge, right? And this carbon will be having positive charge. Yes or no, guys? Please tell me. Vishnu Priya, is it okay? So now, so the addition product can be what? This Br will go to this carbon, right? And this H will go, Br minus is there and H plus is there. So there will be, this product can be there, yes or no? So this is first case, right? Now the second case would be what? If this double bond is shifting towards this carbon, see here, carbon. So double bond has been shifted to this carbon. This is what? Third carbon, let's suppose I'm telling. Although this is not third one, right? This is first carbon, this is second, and this is third one, right? So it is shifting towards the first carbon. So this will be happening what? This will be having minus charge and this will be having positive charge. Yes. Now HBr will be having what? H plus and Br minus again. Now this Br will shift to this carbon and this H will be shifting to this carbon. Yes. Now what will happen? Carbon and Br will be here with the middle carbon, right? And this H will be with this carbon, and rest of the things will be as it is, guys, right? This is the what? This is the addition product. Now you may ask me one question. So sir, you have done 2 ways. So which one is better one? Getting my point? So anyone who can tell me that which one is better one? This is first and this is second one. So which one is better one? See guys, Markovnikov rule. According to Markovnikov rule, this one will be giving you the major product, and this one will be the minor product, right? Right? According to the Markovnikov rule, this one is what? The carbon having the lesser number of hydrogen. The carbon having the lesser number of hydrogen will be having the what? Negative part. That is what? Halogen part. Is it okay? And carbon having the more number of hydrogen will be having the hydrogen part. Is it okay? Clear everyone? So now see here. When the alkene and unsymmetrical, the 2 products are possible. For example, when propene is treated with HBr, both one bromopropene and 2 bromopropene may be formed as the product. Hence, in this case, the addition is governed by the Markovnikov rule proposed by a Russian chemist Markovnikov. It states that what? See here. So it states that what? The Br will shift to that carbon which is having the lesser number of hydrogen. This Markovnikov is saying, right? So you will be seeing here. During the addition across unsymmetrical multiple bond, the negative part of the adentum, that is attacking molecule, joins with the carbon atom which carries lesser number of hydrogen atom, while the positive part goes to the carbon atom with larger number of hydrogen atom. Got my point, everyone? So if I will be going to give you some questions, will you be able to do that or not? Please tell me that. Question is what? So you can see here, this is what? Br will go to that carbon which is having the lesser number of hydrogen, and H will go to that carbon which is having the greater number of hydrogen. Getting my point? So here you can see this is what? 10%, and here you can see that 90%. Br has shifted to that carbon which is having the lesser number of hydrogen. So this is the major product and this is the minor product. So in every case you have to use what? Markovnikov rule. Yes, everyone? Any doubt? Vishnupriya? Any doubt? Fine. Clear, everyone? Now, however, a small percentage of this isomer in which the halogen atom negative part is attached to the carbon with more number of hydrogen atom is also formed. That is isomer form, right? But this is in very lesser in amount. Exceptions of Markovnikov rule. Kharas and Mayo observed that the HBr is added to an unsymmetrical double bonded in the presence of organic peroxide. Now the new rule that will be going to come, that is what? HBr, only HBr I'm going to say you guys, not HCl, not HI. I'm not going to talk about this. I'm going to talk about HBr in the presence of what? Peroxide ion. Peroxide. Getting my point? That is what? H2O2. Peroxides, right? In the presence of peroxide, H2O2. So HBr do not follows the Markovnikov rule. HBr follows what? Anti-Markovnikov rule. Clear, everyone? Is it okay? Now see here. According to the anti-Markovnikov rule, in unsymmetrical alkene, guys, tell me what will be the addition product in case of unsymmetrical alkene if anti-Markovnikov rule is applied in the case of HBr in the presence of peroxide ion. I want your answer. Please write in your notebook and then show me. Anil Dev, you are having propene. You have to show. You have to show the addition product in the presence of what? With HBr in the presence of what? In the presence of H2O2 peroxide. What do you think, guys? See what will happen. Carbon, double bond carbon, right? With HBr, right? In the presence of peroxide ion. So what will be the product? This Br will shift to this carbon and this H will shift to this carbon. Is it okay? Are you getting my point, guys? So Kharas and Mayo observed that the HBr is added to the unsymmetrical double bond in the presence of organic peroxides ROOR, benzoyl peroxide C6H5COOO C6H5C6H6. The reaction takes place opposite to the Markovnikov rule. This is known as what? Anti-Markovnikov rule or peroxide effect. It is also called Kharas effect. According to the anti-Markovnikov rule, during addition of HBr to an unsymmetrical alkene, Br atom will join the carbon carrying more hydrogen atoms, while hydrogen atom will go to the carbon atom. That will be that I have shown you here reaction. Is it okay? Clear, everyone? So here this is example. Propene is there, HBr is there in the presence of what? ROOR or H2O2 you can say, right? In this case, this will be happening. So Br is joining to which carbon? The Br is going to join the carbon having the greater number of hydrogen. Clear? Any doubt to anyone? No. It may be noted that only HBr shows the peroxide effect. HF, HCl, HI do not exhibit the peroxide effect, and therefore addition of HF, HCl, and HI takes place according to the Markovnikov's rule even in the presence of peroxides as well. Getting my point? Okay. Why, if you are asking, then there is two cases, right? There will be a good point to understand here is what? If you are knowing about the carbocation, right? Which carbocation is more stable? 1 degree or 2 degree? Vishnupriya, which carbocation is more stable? 1 degree or 2 degree? 2 degree. If 2 degree is more stable, then that will be a Br will be going to attack 2 degree carbon, the more stable product that you will be going to get from there. Is it okay? Till now, you have to learn only the Markovnikov rule, anti-Markovnikov rule. Kharas effect or Markovnikov effect, all are same, right? Kharas effect, see, even in the presence of peroxides, HCl, HI, HF will not be showing anti-Markovnikov rule. Is it okay? But for HBr in the presence of what? Peroxide, there will be anti-Markovnikov rule will be applied. Is it okay? Any doubt to anyone? Anil Dev? Any doubt? No. So according to the Markovnikov rule, we have got this. According to the anti-Markovnikov rule, we have got this. Here HBr is there and peroxide is there. So in case of peroxide, we have got what? This. In case of, if peroxide is not present, then this will be there. This. Here peroxide should be not there. Right? Clear, everyone? Any doubt? Okay, fine. Now see here. With HBr, we have got what? Br, 2-bromomethyl butane. This is what? Major product. HBr is there, but here no peroxide is there. Until unless if there will be no peroxide, we cannot say that Br will go to this carbon, right? If peroxide is not there, then Br will be adding according to the Markovnikov rule. Right? Now, explanation of this Markovnikov rule about the carbocation that I have told you, right? So 2 degree carbocation is more stable than 1 degree carbocation. Clear, everyone? Any doubt? So we have seen these things. Now, the product is in accordance with the Markovnikov rule. Thus, Markovnikov rule may also stated that in alternative forms, electrophilic addition to an unsymmetrical alkene always occurs through of a more stable carbocation intermediate. So we have seen that this carbocation intermediate is more stable, and you can see here this is carbocation is more stable. 2 degree is more stable than 1 degree carbocation. That's why 2-bromopropane is more stable. Clear? Guys, we have discussed these things that the carbocation, 2 degree carbocation is more stable. So 2 degree carbocation will be formed instead of 1 degree carbocation because it is more stable. Clear? No. About the peroxide effect. See, Kharas and Mayo discovered that the addition of HBr to unsymmetrical alkene in the presence of organic peroxides such as benzoyl C6H5CO, right? OCO C6H5 takes place opposite to the Markovnikov rule. This is known as anti-Markovnikov rule or peroxide effect. According to this rule, Br atoms will join that carbon atom which carries more hydrogen atoms, while the hydrogen atom will go to the carbon that we have seen, right? Now, see here, explanation of anti-Markovnikov rule. See, either in case of free radical, either in case of what? Carbocation. So the Br will go to that carbon which will be having lesser number of hydrogen. You have to take care of these things. So you might be knowing that in case of free radical, 2 degree carbocation is more 2 degree carbon free radical is more stable than 1 degree carbon free radical. In case of carbocation, 2 degree carbocation is more more stable than 1 degree carbocation. Clear? Clear, everyone? So see, the addition of HBr to alkene in the presence of peroxide occurs by free radical mechanism, right? In this mechanism, the first two steps result into the generation of free radical, that is Br plus. Then it adds to the double bond such a way to give more stable radical that we have seen, guys. Now see here. Here there is what? Free radical is there, Br, and carbon free radical is there. So 2 degree free radical is more stable than 1 degree free radical. So more stable will be what? 2 degree free radical will be more stable. Getting my point? So Br will attach to that carbon which is having 2 degree free radical. Clear? No. Because the 2 degree free radical is more stable than 1 degree free radical that we have discussed. Clear? Guys, please tell me if you have not understood anything. Yes, no, Priya? Tell me that, first of all, in case of carbocation, in case of free radical, turn on your mic, then tell me the answer.
Sir, can you repeat the question, sir?
The question is, in case of 2 degree carbocation and 2 degree free radical, which is more stable? Two degree carbocation and 2 degree free radical, which is more stable?
2 degree free radical.
And
Carbocations, sir.
And 2 degree carbocation? They both are more stable, right?
Yes, sir.
Got my point? So one is normal carbon, one is carbocation, or one is what? 2 degree carbocation or 1 degree carbocation, which is more stable?
2 degree carbocations, sir.
2 degree free radical and 1 degree free radical, which is more stable?
1 degree free radical.
2 degree free radical is more stable. I have made you right in the previous classes. So 2 degree free radical is more stable, right? So now, so the Br will go to that carbon which is having more stability, or the Br will go to that carbon which is having less stability?
More stability will be found, sir.
So the Br minus will be going to the 2 degree carbocation,
Yes,
or
sir.
the Br minus will go to the 2 degree free radical? Yes?
Yes, sir.
Yeah, Br minus will go to that 2 degree free radical. So that we were discussing here from that time, right? See here. So here you can see that Br has joined to 2 degree here. Got my point? So either 2 degree carbocation, 2 degree carbocation, or 2 degree free radical. In both cases, these two are more stable. In comparison to 1 degree carbocation or 1 degree free radical. Got my point?
Yes, sir.
Okay, fine. Now we are going to see rearrangement of carbocation, guys. Now, Vishnupriya, you can turn off your mic. What is the meaning of this rearrangement? Let's suppose you are studying, you are living in your home. You are having what? 3 BHK flat in Chennai. Everyone is having flat in Chennai. You all are from Chennai only, right? So you all are having what? 3 BHK flat in your home. Now what happens? Your brother or your sister migrated to America in Google for work, for working in Google, right? Where he has gone? America. Or you might be thinking, oh, if there will be a chance to go to America for me, then it will be really a great moment for me, right? Yes, guys. So after completing IT, you might be going there, right? So your brother or sister has migrated to USA for working in Google, right? Now what happens? So there is a vacancy now, right? So there is a vacancy. What vacancy is there? Now you can do what your mother or father has told you what. Now you can shift your room to that room. It's your choice. Got my point? You can shift your room to that room where your brother and sister was staying there. Getting my point? So you might be thinking, oh, this room is having AC. My room is not having AC. So I should migrate that room. So what has happened? Just rearrangement has happened. You are even now also you are staying in the same home, but the room has been changed. And the goods of your brother and sister has been shifted to your room. Getting my point? That has not been, that has not been eliminated from the room, but that has been shifted to your room. Her goods and services has been shifted to your room, and you have shifted to your brother's room or sister's room. Yes. So that is what rearrangement has been happened there. So in the similar way, here there will be also a rearrangement will be there in the organic chemistry. So how this happens? See here. You can see here, we have learned the addition of HBr to alkene occurs through the formation of carbocation. Sometimes it observed that the product formed is different from the one expected. This is because of the rearrangement of carbocation. Carbocation initially formed can rearrange to form more stable carbocation if the structure of the alkyl group permits. See here. Double bond is there, right? You can see here, there is what? Double bond is there. So now you can see here, this carbon is having what? Carbocation, because this is what? This carbon is 3 degree carbocation, right? So this is what? But here there is no chance of carbocation. Carbocation will form either this place or this place, right? But 2 degree is more stable. So this carbocation will be there. So you can see here carbocation. But what we are going to see, this hydrogen from this carbon shifted towards where? Shifted towards the next carbon. So you can see here hydrogen from this carbon has shifted this carbon. Now what has happened? This is the first step of rearrangement. This is called as what? Hydrogen shift or hydride shift, because hydrogen will take its electron and the electron from the carbon and shift to the adjacent carbon. Getting my point? Is it okay? Now what will be happening? There will be a carbocation will be generated. Now this carbocation will be having what? 3 degree carbocation, and we are knowing that 3 degree carbocation is more stable than 2 degree carbocation. Clear? 3 degree carbocation is more stable than 2 degree carbocation. Is it okay, guys? Any doubt to anyone? So due to this rearrangement, we have got what? A carbocation we have got, and the Br has shifted to this carbocation that is having the 3 degree carbocation, right? Clear? If there is any doubt, then please ask me. Now guys, so we have seen the hydride shift. Now we are going to see what? Methyl shift. See, we observe that 2 degree carbocation rearranges to 3 degree carbocation because of 3 degree carbocation is more stable than 2 degree carbocation. This is called what? 1,2 hydride shift. This is what? 1,2 hydride shift. See here, double bond will shift toward this carbon, or double bonds will shift towards this carbon. This carbon 2 degree carbon, but in this case 1 degree carbocation. So this is not good, right? Now what will happen? This CH3 will shift towards this carbon, right? Now, and this carbon will shift to this carbon. So this will become what? See, you can see here, this carbon, the CH3 from this carbon will go to this carbon, right? Now this is happening, and this is 3-degree carbocation. This is more stable, and Br will attack to this carbocation. So see here, this is what a 4-degree carbon is there. Now you may ask me, sir, if 4-degree carbon, if this is a 4-degree carbon, so this is already more stable. If this is a 4-degree carbon, this is already more stable. Then why are you doing the reactions here? Actually, here is 4-degree, but this is not 4-degree carbocation. We have to make what 4-degree 3-degree carbocation, or because this carbon is what? This carbon is what? This carbon is 2-degree carbocation. We have done what? We have created 3-degree carbocation. We have just shifted this CH3 to this carbon only. Getting my point? So how this methyl shift has happened? Clear, everyone? If there is any doubt, then please check. Please have a note and then tell me. Please guys, please note this. If there is any doubt, then please ask me. So methyl shift is okay with everyone? No doubt? So see guys here. Now next is what? This is called 1,2 methyl shift. So if the structure permits, the rearrangement occurs in such a way that a less stable carbocation is converted to a more stable carbocation. The rearrangement can occur only if a 1,2 shift of hydrogen or alkyl can form a stable carbocation. The product obtained are those formed from the rearranged carbocation, major product, and not from the original ones. See here. So here again, this is what? This double bond is there, so it will be break down. So this will be a what? Carbocation will be formed here, right? No. What will happen there? What will happen then? See guys. Br will attack to this carbon because here there is what? If the electron will move towards this, so here there will be what? Minus charge will be there and plus charge will be there, right? But this is what? This is not much stable. Getting my point? So there will be what? Rearrangement will be there. Clear, everyone? Is it okay? See what will happen. First see here. Br will attack to this carbon. right? And then what will happen? This H will shift towards this carbon, and then Br will shift it to this carbon. There will be a methyl shift will be there. Clear? No, we will be going to seeing the isomerism in alkynes, right? The next topic will be what? Isomerism in alkynes. So have a break of 5 to 7 minutes. Then we will see this. Hello everyone. Are you there? Please turn on your camera. So guys, we can see here the isomerism. This is what chain isomerism in alkyne, right? We have done what? We have taken this CS3, right, to this carbon. So we have got what? Shorter chain. Earlier it was what? 5 chain carbon. Now it is having what? 4 chain carbon. So this is known as what? Chain isomerism. Chain isomerism is a part of structural isomerism, right? So these things we have seen earlier as well, right? We can also see the position isomerism in alkynes, right? So the position of this triple bond has been changed from first carbon to the second carbon. So we can see what? The position isomerism as well. So chain isomerism and position isomerism, right? Now, functional isomerism, see here. Alkynes have 4 more carbon atoms, right? Are functional isomers of dienes compound containing 2 double bonds, right? So see here, 2 double bond, that is what? Dienes. Getting my point? So this triple bond, 4 carbon, now we are having what? 2 double bonds, right? So butat 1,2-diene. Now ring chain isomerism, what is happening here? Alkynes are isomeric with cycloalkanes containing the same number of carbon atoms. You can see here, this is triple bond. Now it is having what? Double bond. So it is what? Ring chain isomerism. It is what? You can say that ring chain isomerism. This is what? Chain. Getting my point? So you can see here also 4 carbon chain, triple bond is there. This is having what? Triple bond at double second carbon, and this is having what? A ring chain isomers. So alkynes is having what? Chain isomerism, then position isomerism, then functional group isomerism, then ring chain isomerism, right? No geometrical isomerism. So we are not having geometrical isomerism in case of alkynes. We are having in case of alkenes only. Now, it may be noted that the alkynes are linear molecules. So C triple bond, C H bond angle is 180 degree. Therefore, alkynes do not show geometrical isomerism. Now, we are going to see preparation of alkynes, right? So there are different methods by which we can prepare alkynes, and then we will be going to see the properties. So we are going to see that first. So how we can prepare this alkynes? See here. In the last class, we have seen the preparation of alkenes. Now we are going to see the preparation of alkynes. See here. Alkynes are prepared by the following general methods. First one is what? Action of water on calcium carbide. Ethyne is prepared. Ethyne is prepared in the laboratory as well as in industrial scale by the action of water on the calcium carbide. See here. CaC2 is there. In the presence of what? Water, you will be getting what? Ethyne. Calcium carbide requires two for this purpose is obtained by heating calcium oxide, that is what? Limestone, and coke is an electric furnace. So we will be getting what? Ca and CO2. Now, CaO with 3 carbon, we will be getting what? CaC2 and CaO. Now, see here, by dehydrogenation reaction of dihalides to vinyl dihalides. So in this case also we will be getting what? Alkynes. So alkynes are prepared by double dehydrohalogenations of vinyl dihalides containing 2 halogen atoms on the adjacent carbon atoms with strong base like alcoholic solutions of potassium hydroxide or sodamide in liquid ammonia. So there are different methods to prepare this, alkynes. CH2Br with alcoholic KOH, you can see here we will be getting what? Acetylene. Here also we are getting what? CH3CH, CHBr, R is there. We are getting what? Propyne will be there, triple bond will be there. Now, so in all these cases we are getting what? That alkynes. Getting my point? See here. So NH2 group is attaching with this nitrogen. See here, H is there. Here there is what? NH2, minus charge will be there, right? Hydrogen and nitrogen. Nitrogen will try to pull out the electron from the hydrogen as nitrogen is more electronegative, right? So in this case also we'll be getting what? This X will be removed from here. So you can see here, this carbon is having only 3 bonds. So there will be what? Triple bond will be there, right? So we'll be getting what? Alkyne. Now, action of C. If there will be what? Zinc will be there on tetrahalogen derivatives of alkenes, that is what? Tetrahalides. On treatment with zinc in methanol, tetrahalides get dehalogenated to give alkynes. So by the actions of zinc, we will be getting what? Tetrahalide, and you will be getting what? Alkyne will be formed. So there are different methods. By higher alkynes or acetylene, then also we will be getting what? Triple bond. So there are different methods by which we can prepare alkynes, right? By electrolysis of aqueous solution of potassium salt of fumaric acid, then also we will be getting what? Alkynes. So guys, please check what are the different methods by which we can prepare alkynes. If there is any doubt till here, please ask me. See, if you will go to see your book, that is NCRT, so there are only 2 methods has been given. from calcium carbide and from what? Vinyl dihalides. I have given you so many methods by which you can prepare what? Alkynes. Got my point, everyone? So there are so many methods, so I'm not going to explain all the methods, but few methods I have discussed, 4 to 5. Only 2 methods has been given in your syllabus, right? Now we are going to see the physical properties of these alkynes. The first 3 members, ethyne, propyne, butane of the family are gases at room temperature. The next 8 liquids, while the higher one are solids. So 3 are what? Gas. Next 8 are what? That is liquid, and rest will be what? Solid. Clear, everyone? 8 are liquid while the higher ones are solids. All alkynes are colorless. However, the ethyne has characteristic odor or garlic smell. Clear? Solubility: alkynes are weakly polar in nature. They are lighter than water and immiscible with water, but are soluble in organic solvents such as petroleum, ether, carbon tetrachloride, benzene, etc. So they are lighter than water. So they are not soluble in water, right? So they will be they are soluble in petroleum, ether, carbon tetrachloride, benzene, etc. Right? Now we are going to see melting point and boiling point. So guys, melting point and boiling points of the members of family are slightly higher as compared to those of corresponding member of alkene and alkene families. So melting point and boiling point will be greater than alkene and alkane. Clear? This is due to the fact that the alkynes have linear structure and therefore their molecules are more closely packed in space compared to the alkanes and alkenes. The magnitude of attractive force among them are higher, and therefore melting and boiling points are also higher. Melting and boiling points increases with increase in molecular mass of the alkynes. Now we are going to see the chemical properties of these alkynes, right? So the first chemical properties that we are going to see is what? Acidic character of alkynes. See, acetylene and other terminal alkyne, 1-alkyne C, are weakly acidic in character. They react with strong waste like sodium metal, 475 Kelvin temperature, and soda amide, NaNH2 in liquid ammonia at 196 Kelvin temperature to form what? Acetaldehyde derivatives known as acetaldehydes or alkynides with the liberation of what? Dihydrogen gas. Clear? Clear, everyone? Next. So these are the reactions that we are having. See here. Please first check 1 to 2 reactions, then we will be going ahead. See guys, this is alkyne, react with what? Sodium. This is giving what? Monosodium ethanide. See here. Ethyne reacted with this sodium, Na plus and C minus. We are having what? Although always we are saying C plus, but Na plus and C minus will be there. So we are getting what? Disodium ethanide. Clear? So we are having what? We are getting this. This is the chemical properties of this alkynes group. Sodium alkanide is decomposed by water regenerating alkynes. Clear? So you can see here, this is what? Triple bond, Na plus with water. It will be giving what? Alkyne, and NaOH group will be there. This shows that water is a stronger acid than alkynes and therefore displaces alkyne from sodium alkaline. So water is more acidic than alkynes. Clear? See, acetaldehyde reacts with alkyl halides to give higher alkenes. You can see here CNA CH3Br, right? So it will give what? Carbon triple bond carbon and NABr. So the acetylic hydrogen of alkynes can be replaced by copper 1 or silver 1 ions. They react with ammonical solutions of cuprous chloride, right? And ammonical silver nitrate solution called Tollens region to form what? Corresponding copper and silver alkanides. So we have to learn this chemical reactions, right? No. Addition reaction. In triple bond, what we are happening, this is what? Carbon triple bond carbon. In the presence of what? This electrophile X2. So we'll be getting what? Triple bond will be break down into double bond, and again the double bond will be break down into single bond. So we'll be getting what? Here it is happening what? That is hydrogenation is happening. Hydrogenation is happening. So in this case we are getting what? We are getting alkane or ethane, you can say. Like alkenes, alkynes undergo addition reaction due to their unsaturated nature. However, in alkynes, the addition occurs in two. One molecule of attacking reagent is added to the alkyne and its triple bond changes to double bond. In the second step, second molecule of reagent is added to which changes double bond into a single bond and saturated compound is obtained. So from unsaturated, we are getting what? Saturated one. Saturated one. So in two steps we are getting saturated, but in case of alkene we are directly getting what? Saturated carbon single bond carbon. Now addition of halogen. So triple bond. So triple bond will be break down into double bond. So we'll be getting what? Cl, and again it will be break down. So we'll be getting what? This double bond will be not there. Single bond will be there, right? So we'll be getting what? Tetrachloroethane. Clear? This is the addition of a halogen. Now guys, how this tetrahalogen will be happening? See here, what will be the case? So in the case of what? Addition of halogen acids to alkyne is an electrophilic addition reaction similar to alkenes. To occur two states and with part decide the stability of carbocation formed. See here, triple bond is there. So this triple bond will break down and HCl is there, right? So H plus and Cl minus. So we'll be getting what? CH plus. In the first stage, we'll getting what? This, if double bond will shift towards this side. So plus charge will be developed here. So you can see here the plus charge is here. So Cl minus will be attacking this side. So we'll be getting what? CH2 double bond CHCl. Getting my point? Triple bond breakdown. This will be shifting towards this. So it will be having what? Plus charge. And this will be having what? Minus charge. And H plus and Cl minus is there. So Cl minus will attack to this side and H plus will attack to this side, which we have, sorry, Cl minus will attack to this side because this is having what? Minus charge. So Cl minus will attack to this side and H plus will attack to this side. So this is an addition reaction mechanism. Getting my point? Clear everyone? So we have to also check whether which carbocation is more stable. So based on the carbocation stability, that will be the major product. So higher carbocation stability, like more degree carbocation, will be more stable compound will be formed. Now, addition of hypohalous acid, that is HOX. Alkynes react with two molecules of hypohalous acid, HOCl and HOBr, or halogen Cl2Br2 in the presence of H2O. So we'll be getting again what? See here, dichloroacetone we are getting in this case, hypohalous acid. So we will be following the what? Markovnikov rule. Please check the Cl will go to which carbon and OH will go to which carbon, guys. See here, in this case, what we are getting, OH is this coming to this carbon. This carbon is 2 degree carbocation and this carbon is 1 degree carbocation. But here, what is happening here? In case of Cl and OH, OH is more electronegative. So here it will be what? this will be having the minus charge and this will be having the plus charge. So OH will be attached to that carbon which is having the more carbocation stability. So the final compound will be forming what? OH will shift to this carbon only. Clear everyone? According to the Markovnikov rule. Now, addition of water of alkynes. Just give me a moment. Just I am first assigning you the class assessment. Then we will be looking ahead. Guys, please check the class assessment has been assigned to you or not. Is it visible to everyone? Okay. Now, see first here, when I will say you to do that, then only you have to do that, right? Addition of water, that is what? Hydration of alkynes. Like alkanes and alkenes, alkynes are also immiscible and do not react with water, that we have seen. However, alkynes react with water in the presence of mercuric sulfate, HgSO4, and sulfuric acid, 333 Kelvin temperature. The product are carbonyl compounds, aldehyde and ketones. In the reaction, first enol is formed, which contain double bond, that is ene, and alcoholic group, that is ol. But the enol formed is quite unstable in the acidic condition. So its isomer is more stable keto form as a result of rearrangement. So you can see here, ethyne react with HgSO4. So give what? Vinyl alcohol. And then finally we have got what? Isomerization of this will give what? Ethanol. That is what? Aldehyde. In case of unsymmetrical alkyne, the addition occurs in accordance with the Markovnikov rule. And we are knowing that Markovnikov rule is what? We have seen these things. Clear, everyone? So the rearrangement of enol form, keto form is called tautomerism. Tautomerism we have seen in isomerism. Now, addition of hydrogen cyanide. Alkynes react with hydrogen cyanide as seen in the presence of what? Barium cyanide catalyst. Acetylene gives vinyl cyanide or acryl nitrile, which can be used for preparation of synthetic fiber, that is orlon. See here. So we have to learn these things, guys. What will react and what will be formed. So in this case, which will be formed? Vinyl cyanide will be formed. Clear, everyone? So alkyne will be converted into what? Vinyl cyanide in the presence of BaCN2. Clear? Now we are going to see the addition of alcohol and carboxylic acid, right? Ethyne adds a molecule of alcohol in the presence of alkali to give vinyl ether. So see here, guys, what will happen in the presence of alcoholic KOH. So there will be what? Triple bond will be there. So alcoholic KOH, CH3OH is there. So what will be formed? Methyl vinyl ether will be formed. Alkynes adds acid presence of Lewis acid catalyst. So here we will be getting what? This is CH3COH in the presence of CH3COH. We will be getting what? Vinyl acetate. And further reaction with Hg2 plus, we will be getting what? Ethylene diene acetate. So in this reaction, we are seeing that ethylene diacetate on hitting 573 Kelvin temperature, we are getting what? CH3, CSCO, OCH3, we are getting what? Aldehyde, and this is what? Acetate anhydride. And the last is what? We are going to see addition of a hydrogen, and then polymerization reaction will be seen in the next class. See. Addition of hydrogen, that is hydrogenation reaction. So that we have seen in alkene also. So here also double bond will break down and single bond will be formed, and hydrogen can be added in the presence of nickel, palladium, platinum. If triple bond will be there, that is alkyne, then also it will be converted into alkene first, then alkane as well. And in that case, hydrogen will be added in the presence of nickel, palladium, platinum. Clear? So from propine, we have got what? Propane. Now, Lindlar's catalyst. So it may be noted that the hydrogenation can be controlled at the alkene stage only. This is possible by using Lindlar's catalyst, which is a mixture of palladium and barium sulfate poisoned by quinoline, right? It allows the hydrogenation of alkynes only to the alkene stage only. So this reagent will help to, because from alkynes we can form what? Alkene, and further we can make what? Alkane. But this Lindlar's reaction check to this level only. This will not further proceed. This alkene will not be converted into alkane with this reagent only. So PD BaSO4 will be used in that case to check with the alkenes, to check at the alkene level. Clear? Now, however, chemical reduction known as Birch reduction of non-terminal alkynes with sodium or lithium or in liquid NH3 at 195 to 200 Kelvin gives transalkene. See here, this is what? But2-ine In the presence of sodium and that is mercury, we are getting what? Trans, CH3, CH3. This is in opposite direction. We are getting what? Trans alkane. So polymerization reaction that we will be seeing in the next class, and cyclic polymerization reaction that we will be seeing in the next class. This is a summary, guys. Whatever be the reaction that we have seen in today's class, this has been given in a summary form. I hope this will be a very important for you to learn, and I hope this will really help you to understand this part. Today's what we have seen.